Hello, everyone, and welcome back to Unit 1 of Physical Science. Last time we talked about the nature of science, dealing with the scientific method. I might have mentioned that that was Notes 2, but that was actually a continuation of Notes 1. Today is actually Notes 2, where we actually will discuss scientific notation. So the PDF for that can be found in Canvas right here, Notes 2 Scientific Notation. And of course, if you need to access this lecture later, you could just click on it here, Notes 2 lecture, and rewatch this video. So the notes for this look like this. It's very simple today. It's just two sheets of paper here, one sheet of paper front and back. And it's going to be very few practice problems, but there are a couple of homework problems based off of this. So we really want to pay attention on how to nail this down. A little bit of a warning, there's a lot of math involved today, but it's not super difficult math. It's just, adding, subtracting, multiplying, and dividing, stuff that you should be able to handle right now. So without further ado, let's go ahead and jump into Notes 2 on scientific notation. So what exactly is scientific notation? Well, in science, we often have to deal with either really big or really small numbers. And oftentimes we have to do some type of math involving those really big or really small numbers. And having to write those really big, really small numbers out a lot can be kind of cumbersome and tiresome. And sometimes we might miss a zero or two, which can really mess up a lot of our calculations. So even just throwing in an extra zero can drastically change, how your math calculation comes out. If you really think about it, like if you throw in an extra zero into any aspect of your life, like let's say you have someone that makes, for instance, $80,000 a year, which is a pretty good salary for someone. If you throw in an extra zero, $800,000 a year is a really good salary. That's well more than a lot of people make. So just one extra zero can make a big difference. The other way is true too. Like if you took away a zero, $8,000 a year, that's not a lot of money for someone to be making in a year. So, throwing in an extra zero here or there can kind of confuse people. And we got to be really careful when we're dealing with really big or really small numbers that have a lot of zeros or not enough zeros, because we want to make sure our math is right. So I've got an example for you. For example, in chemistry, we often use a number called Avogadro's number, and it's a very large number. It's this number right here. It's 602,252, and then a whole bunch of zeros behind it. And if we mess up this number, it can mess up our calculations for calculating how much of a certain chemical we have or how much of a certain compound we have. So we got to make sure that we are counting our zeros properly, and the way we do that is a really easy way called scientific notation. Now, scientific notation is the method of writing or displaying the numbers in a way that is much easier to read. All right, it shows the numbers in terms of a decimal number between 1 and 10, and then we take that number and we multiply it by a power of 10. So, for example, going back to Avogadro's number before, this massive number that I just showed you before, if we were to write that in scientific notation, which we do in chemistry, we would write it like this. Much easier to read, much easier to type into a calculator, and much easier to work with and make sure that we are not making any mistakes. So 6.02 times 10 to the 23rd is a number that we use in chemistry to calculate, how much of a compound we have, how much of a chemical we have. So much easier to type in, and this is something that is pretty standard in science, and we got to make sure that we understand how to write it and how to do math with it. All right. Another example that I can give you is the distance from the sun to the earth, which varies very little, but about 93 million miles is that number right there. From the sun to the earth, approximately 93 million miles away. All right. Not as many zeros as the number that we saw before, but still we want to make sure that we write this number in scientific notation so that we don't mess up our zeros and we don't mess up the number when doing some type of math calculation. So instead of writing it like this or typing it into a calculator with 9-3 followed by 6 zeros, you can simplify it to write 9.3 times 10 to the 7th. And I'll show you how we got that in a little bit. So 9.3 times 10 to the 7th. And before I move forward, the way we got that is we have this decimal right here, the 9.3, which looks very similar to the 93 right there. If we just consider this number right here, the 93 million, and we put a decimal here, right now there is no decimal, but if we were to put a decimal, that decimal would be right there at the very end, all right? But over here, the decimal is right there between the 9 and the 3. So if we moved that decimal until it went between the 9 and the 3, it would go like this: 1, 2, 3, 4, 5, 6, 7 spaces to the left. And so that right there, keep fast forwarding here, right there, 9.3 is where we want that decimal. And we moved that decimal 7 times. So it's not a coincidence that since we moved that decimal 7 times, we multiplied by 10 to the 7th. And that's where that exponent comes in, that 7. All right? So the whole point of scientific notation is to remove extra zeros from the numbers to make them smaller. Again, easier to calculate, easier to read, easier to work with. Here's another example. 300 million meters per second. This is the speed of light in meters per second. If you're not familiar with a meter, it's a little bit longer than a yard. It's about 39 inches or so and some change, just a little bit longer than a yard, and that's 1 meter. So if we cover 300 million of those in 1 second, that's the speed of light. All right. So later on this year, actually, in second semester, we are going to be dealing with this number quite a bit, this 300 million meters per second. But we are not going to be writing it like this because there will definitely be mistakes with people typing it into a calculator. I see it all the time where people type in 3 million or 30 million or sometimes even 3 billion. All of those numbers are not the same as 300 million. So we got to make sure we type it in correct. And if we type it in a scientific notation, we see that it ends up like this: 3.0 times 10 to the 8th meters per second. Okay, so that's the third number that you've seen so far in this presentation written out in scientific notation. And at this point, you might see a connection here, or like how we write out scientific notation. We've got this number in the front here that's represented as a decimal. We've got the multiplication symbol, and then we have 10 raised to some power. So that's always going to be the case. That's the format. It's always times 10 to the something. Okay? So that's the beginning of scientific notation. Let's go ahead and break that down a little bit. If we move the decimal to the left, that exponent that's above the 10 is going to be positive. Okay, so going back to 3 million meters per second, let's go ahead and move this decimal until it shows up between the 3 and the 0 here. So we're going to move it 1, 2, 3, 4, 5, 6, 7, 8 times. So we moved it 8 times, and that's where this 8 comes in. And we moved it to the left, which means that it is becoming more positive. But just once again, when we move the decimal to the left, the exponent is becoming more positive for every time we move to the left. So going back to this previous slide, I've got another example here of just a random number. We got this number, 23 million kilometers. If we want to write this out in scientific notation, what we're going to do is actually put in the decimal somewhere over here so that we have a smaller number in front. And so let's go ahead and move it left 7 spaces. Here's my decimal, and I'm going to move it left 1, 2, 3, 4, 5, 6, 7 times. So the number that I have now in front is going to be 2.3 because I put the decimal right there between the 2 and the 3. So that's the first number, 2.3. And then following the same format, it's times 10 to the something. And that something is the number of times I had to move that decimal over so that it landed where I wanted it to land. So in this case, I moved it 7 times to the left. It's a positive exponent, so it's times 10 to the 7th. All right. How about if we move the decimal the other way? What if we move the decimal to the right? All right, well then in that case, I end up with a negative exponent. Remember, in the beginning of this lesson, I talked about how we could deal with really big or really small numbers. So far, we've been only dealing with really big numbers. So what happens when we deal with a really small number? Because sometimes we are measuring something really, really, really small, and we need a measurement that's accurate, so we have a really small number. In that case, let's go ahead and take a look here. I'm going to set up my first decimal to be, or the first number in the front to have a decimal that's somewhere over here. And so I'm going to move this to the right 6 spaces. 1, 2, 3, 4, 5, 6. I moved the decimal to the right 6 spaces. So now my new decimal is between 6 and 7. So I have 6.7 as the beginning, times 10 to the, and then over here, because I moved it to the right this time, the exponent is going to be negative. So it's times 10 to the negative 6th. All right. So some vocabulary here. These are going to be some funny names here. You probably know what this number is here, that's notated here as the number 7. That is going to be called the exponent, which you already know. But this number in front, the 9.3, whatever this number it is here, it has a special name. And that special name is the mantissa. Okay, so that's kind of a funny name, but that's just the name of what that number is in front. So there's two parts to the scientific notation. We've got the mantissa, and then we've got, of course, the exponent, which is something that you probably already knew. So there's two parts that always change, but the times 10 always remains the same. That's going to be part of the scientific notation that is going to be the same. The mantissa and the exponent might change depending on what big or small number you're dealing with initially. So when you're writing down your numbers in scientific notation, you have to make sure that that mantissa is greater than or equal to 1, but less than 10. Okay? So greater than or equal to 1, or less than 10. This is very key when changing numbers from standard notation to scientific notation. The mantissa has to be between 1 and 10. So let's go back actually a slide here. And the reason why we chose 6.7 and maybe not 67 is because we wanted this mantissa right here to be between 1 and 10. If we moved that decimal one more time from here to here so that it was 67, 67 is not a number that is between 1 and 10. So that's the reason why we chose that point for our mantissa, or for the decimal. So when it comes to actually doing math in scientific notation, most of the time we are dealing with numbers that are really big and really small, and then we are multiplying or dividing them. Very few times are we actually adding or subtracting them. So what we're going to do now is actually do a couple of practice problems in which we are multiplying or dividing numbers in scientific notation. So for multiplication, the rules are actually fairly easy. What you want to do is multiply the mantissas as if they're normal numbers. Just take the first mantissa, multiply by the second mantissa. You could even do it in your calculator if you want to. And then the next step is to add the exponents. You're not going to multiply the exponents, you're just simply adding them. But just remember that the mantissa has to have only one number in front of the decimal. So whatever number you get when you multiply those two numbers together, the two initial mantissas, the answer, the mantissa in the answer must have only one number in front of the decimal. So just keep that in mind when we take a look at this practice problem here. So a group discussion problem. If we have 3.0 times 10 to the fourth multiplied by 4.0 times 10 to the third, what are we going to get? Well, if we follow the rules from the previous slide, what's the first step? We have to multiply the mantissas. So the mantissa here is 3. So we have 3 times this mantissa, which is 4. 3 times 4 is easy. That's 12. And then the next step is to add the exponents. So the exponent here is 4. Exponent here is 3. 4 plus 3 is 7. So the answer you should have gotten was 12.0 times 10 to the 7th. However, we are not done because this answer is not in scientific notation. And the reason why it's not in scientific notation, again, is because this mantissa is not a number that is between 1 and 10. Okay, 12 is greater than 10. So we have to fix that in order to make sure that it's in scientific notation. Go ahead and think about this for a second and think about how can you fix this so that it actually is in scientific notation. Well, if you've thought about it, maybe dwelt on it a little bit, the mantissa is bigger than 10, so we actually need to move that decimal one more time. We got to move it over one more time to the right between the 1 and the 2. Okay, so we get 1.2, But because we moved that decimal in the mantissa, we actually have to increase the exponent. How much do we increase that exponent though? So we moved that decimal once to the left, one time to the left. And remember, every single time we move a decimal to the left, the exponent increases one time. So now the correct answer is 1.2 times 10 to the 8th. Okay, so we went from 12.0 times 10 to the 7th to 1.2 times 10 to the 8th. Now, mathematically, those two numbers are the exact same. 12 times 10 to the 7th and 1.2 times 10 to the 8th, mathematically, in a calculator, is the exact same number. But there is a correct way to write these numbers in the scientific community. So in scientific notation, that mantissa has to be between 1 and 10. All right? Division is just as easy as multiplication. You are instead going to divide the mantissas instead of multiplying them. And in a multiplication, we added the exponents. So you can probably guess what we're going to do in a division. We are going to subtract the exponents. Okay, you're always going to do the bigger number minus a smaller number, bigger exponent minus a smaller exponent. And just like in multiplication, the mantissa must have only one number in front of the decimal. So let's go ahead and take a look at that problem really quick. We've got this group discussion problem, which is 2.0 times 10 to the 7th divided by 4.0 times 10 to the 3rd. Okay, so we've got this larger number times 10 to the 7th means that it's a much larger number than times 10 to the 3rd. 2.0 times 10 to the 7 divided by 4.0 times 10 to the 3rd. The first step was, again, to divide the mantissas just like normal. So 2 divided by 4. 2 divided by 4 is 1/2. It's 0.5. Okay, so that's the first mantissa. And then for the exponents, we are just simply subtracting them. So 7 minus 3 is 4. So the answer we should have gotten was 0.5, 1/2, times 10 to the 4th. All right, but once again, that mantissa is not between 1 and 10. 0.5 is less than 1. Therefore, we need to move that decimal so that the mantissa is between 1 and 10. So in order to move that decimal, I'm going to just move it one time to the right so that my new mantissa is 5. Okay, mantissa is less than 1, so I move that decimal one time over to get 5. But when I move my decimal to the right, my exponent actually decreases 1 in value for every time I move the decimal. So I went from 4 to 3, so the new answer is 5.0 times 10 to the 3rd. All right, that concludes Unit 1, Notes 2 on scientific notation. There should be an assignment in Canvas, so let's go ahead and take a look at that. So in Canvas, there is this assignment right here, Scientific Notation Practice. Go ahead and take that. This is an automated quiz, so you get feedback right away. It is a quiz format, but it is under the homework, the assignments and worksheets category. It says right here, assignments and worksheets. There is no time limit, and you can take this multiple times. Okay, so go ahead and answer these questions about scientific notation practice right now.